sharks are older than you think. Long before the first dinosaur walked the earth, sharks were already hunting in the ancient oceans. These are 12 shark species that existed before the age of dinosaurs, explained. Serratolamna lived approximately 70 million years ago, during the final period of the age of dinosaurs. This shark was a fast and agile predator that shared the ocean with mosasaurs and plesiosaurs. Fossil teeth recovered from multiple continents confirm that Serratolamna was widely distributed across ancient seas that no longer exist today. Its teeth structure closely resembles modern sharks, suggesting that the basic design of shark dentition was already highly optimized 70 million years before humans appeared on Earth. Scapanorhynchus lived 80 million years ago and is considered a direct ancestor of the modern goblin shark, one of the strangest sharks alive today. Its elongated rostrum and protruding jaw are nearly identical to its living descendant, making it one of the most direct evolutionary links between prehistoric and modern sharks. Fossils of Scapanorhynchus have been found in North America, Europe, and Asia, confirming it was one of the most widespread predators of the Cretaceous seas. Squalicorax lived 85 million years ago and was one of the most successful predators of the Cretaceous period. Unlike most prehistoric sharks known only from isolated teeth, Squalicorax fossils include rare, complete specimens that allowed scientists to reconstruct its full body. Evidence carved into dinosaur bones suggests that Squalicorax fed on the carcasses of land animals that fell into ancient seas, making it one of the first sharks documented to have eaten dinosaurs. Its serrated teeth are nearly identical in design to those of the modern tiger shark. Ptychodus lived 90 million years ago and was built completely differently from any shark alive today. Instead of sharp-pointed teeth designed for biting flesh, Ptychodus had flat, rounded teeth arranged in a dense pavement pattern across its jaw, designed specifically for crushing the shells of mollusks and sea turtles. Scientists estimate it could reach lengths of over 10 meters, making it one of the largest shell-crushing predators in Earth's history. No modern shark fills the same ecological role that Ptychodus occupied 90 million years ago. Cretoxyrhina lived 100 million years ago and was the apex predator of the Cretaceous seas. Known as the Ginsu shark due to its razor-sharp teeth, this species could reach lengths of 7 meters and was fast enough to hunt mosasaurs, the giant marine reptiles that dominated ancient oceans. Fossil evidence shows Cretoxyrhina teeth embedded in the bones of marine reptiles, confirming direct predatory encounters. Scientists consider it the great white shark of its era, dominant, powerful, and at the top of every food chain it inhabited. Sphenodus lived 180 million years ago during the Jurassic period, making it a true contemporary of the earliest dinosaurs on land. This shark was a slender and fast predator that hunted fish and small marine prey in shallow ancient seas. Fossils recovered in Europe show a body plan surprisingly similar to modern requiem sharks, suggesting that the fundamental design of fast-swimming sharks was already established nearly 200 million years ago. Sphenodus proves that sharks had already reached an advanced evolutionary stage before dinosaurs became dominant on land. Palaeospinax lived 200 million years ago at the boundary between the Triassic and Jurassic periods, surviving the mass extinction event that wiped out over half of all species on Earth. This resilience is one of the most remarkable facts in shark evolution. While entire ecosystems collapsed around it, Palaeospinax continued to thrive in the recovering oceans. Its body structure shows early features of modern sharks, including a more flexible jaw, an evolutionary innovation that would eventually give rise to the diverse shark families we know today. Hybodus lived 260 million years ago and survived not one, but two of the largest mass extinction events in Earth's history. It persisted through the Great Dying, the extinction event that eliminated over 90% of all marine species, and continued thriving for over 180 million years before finally disappearing. Hybodus had two distinct types of teeth: sharp-pointed teeth for catching fish, and flat-crushing teeth for hard-shelled prey, giving it a dietary flexibility that most predators lacked. This adaptability is precisely why it survived so long. Orthacanthus lived 320 million years ago in the freshwater swamp forests that covered much of ancient Europe and North America. Unlike most sharks that require saltwater, Orthacanthus was a freshwater predator, the bull shark of the Carboniferous period. It could reach 3 meters in length and was the dominant predator in environments filled with giant insects, amphibians, and early reptiles. Fossil evidence suggests Orthacanthus was cannibalistic. Its stomach contents included the remains of juvenile sharks of its own species, a behavior still observed in some modern shark species today. Xenacanthus lived 340 million years ago and had a body plan unlike anything seen in modern sharks. A long spine projected from the back of its head, its body was eel-like and flexible, and its paired fins were fringed rather than solid, giving it a highly distinctive silhouette, unlike any shark alive today. It inhabited freshwater rivers and swamps alongside the earliest land-walking vertebrates. Xenacanthus survived for over 200 million years across multiple extinction events, making it one of the most durable shark lineages in the fossil record. Stethacanthus lived 360 million years ago and possessed one of the most bizarre structures ever found in any shark species. The males carried a flat anvil-shaped structure covered in tooth-like scales on top of their dorsal fin, a feature found in no other shark before or since. Scientists still debate its purpose, with theories ranging from mating displays to mimicking the open mouth of a larger predator to deter attacks. Whatever its function, this structure makes Stethacanthus one of the most visually distinctive creatures in the entire history of shark evolution. Stethacanthus lived 360 million years ago and possessed one of the most bizarre structures ever found in any shark species. The males carried a flat anvil-shaped structure covered in tooth-like scales on top of their dorsal fin, a feature found in no other shark before or since. Scientists still debate its purpose, with theories ranging from mating displays to mimicking the open mouth of a larger predator to deter attacks. Whatever its function, this structure makes Stethacanthus one of the most visually distinctive creatures in the entire history of shark evolution. These 12 sharks existed before, during, and long before the age of dinosaurs. Some survived mass extinctions that erased 90% of life on Earth. Others vanished, leaving no living descendants. All of them shaped the oceans into what they are today. Subscribe to Deep Pelagic for more ocean life explained every week.